All right. Last STAAR review. This is going to be short and sweet. For some reason, we are not getting transformations, dilations, rotations, and then we have a little bit of miscellaneous, okay? So, transformations. Transformations is the big category, but there are translations, reflections, rotations, and dilations. Underneath that, they are like subcategories. So, translations. They slide a point of a figure. The rule looks like x plus, y plus. Sometimes they can even write a rule. Let's say they moved right but didn't move up or down. It would be x plus 4y. That means if the y is by itself with no plus or minus, they didn't move up or down. If the x was by itself, it means that they didn't move left or right. Reflections, they flip a point or a figure over an axis. So we've only got two axes, the x-axis and the y-axis. So for us, if you reflect over x, change the sign of y. There's your rule, okay? If you reflect over y, it's change the sign of x. That simple, okay? All right, and with transformations, these do not mean make it negative. They mean change the sign, okay? Rotations. We've been practicing writing these rules. I'm going to go over how I write them one more time, okay? And what I do, I've got it written there, but I'm going to come down here. I do counterclockwise, clockwise. The reason I start out with counterclockwise is because it goes 90, 180, 270. The only other one we need to know is 360. 360 means it stays in the exact same place, so your coordinates are exactly the same way, okay? So the reason I start with that is because this is the opposite. So you're just going in the opposite direction, okay, when you write them. Then I go to 180 and I say, okay, leave the x and y coordinates in the same order, but change the sign of both. 90 is flip the order, but change the sign of y. 270 for counterclockwise is flip the order, but change the sign of x, and it's that simple. I say it when I write it, because I have to, okay? That's how it works for me. Your brain is probably very, very much more sophisticated than mine, and you'll do just fine, okay? So I write this down every time I work a problem with rotations. All right, so we just talked about all of this. Remember 360, you just leave your x and y the same place. This is what they're going to concentrate on. What is the rule for that movement? So they're going to say a figure was rotated 90 degrees clockwise. What's the rule? So if you wrote it, I would go to 90 degrees clockwise. Here's the rule. Okay? All right, flip the page. Congruency. Remember that anything that doesn't change size maintains congruency. That means your angles stay the same, your visual appearance of something might change because if you turn it, a point might be in a different direction, but the angle measures stay the same. Small square, big square. They stay 90 degrees, don't they? So, congruency is translations, reflections, rotations. All right? The angles stay the same, the side lengths stay the same, the figure is the same. It just may visually appear a little different. And I'll show you an example. If I had something like this, okay, and I rotated it, instead of having the point go this way, it may make the point go that way. Okay, so if A was here, now A is over here because I rotated it. Okay, that easy. That's what I mean by visual, all right? Dilations are the only one that do not maintain congruency. They change the size, but not the angle measures, because if you dilate a square, small square, big square, it's still a square, okay? So dilations do not change the angle measures, they just change the size. They will change the side lengths also. A rule is always going to be whatever your scale factor is times y and your scale factor times x, okay? Just like this. It's always multiplication. I've never seen them use division because they just use a number that is less than 1 if they want to make it smaller, which that would be kind of dividing, or they use a number that's greater than 1 if they want to make a number bigger. So it'll either be like 0.5x, 0.5y, or they could use a fraction, 2/3 x, 2/3 y. If they want to make it bigger, they're going to use 1.4x and 1.4y, or they could use a fraction. Remember, just because it's a fraction doesn't mean it's smaller, so they could use 7/5 x, 7/5 y. And look at your figure. Make sure you're marking which one is new and which one is the original. Remember that the hashtag, not the hashtags, the prime sign, so A prime is new, whereas A is the original. Okay? Last thing I want to go over, if you get a question where it says the area of a square is 84 units squared, what is the side length? On your calculator, I'm going to show you this one more time because you guys still get stuck with this sometimes. When you square something, to undo a square, it's the square root sign, okay? So all I would do is do second square root 84, and I would find out that my side length would be 9.16 whatever 5 blah blah blah. Okay, show you in simple terms, if I had a square and it said the area was 25 units squared, okay? That means that if I take the square root to find the side length, second square root 25, it's 5. And let's see if that's true. If I put a 5 here to find the area of a square, it's 5 times 5, which is 25. Do you see that? It's that simple. Have a great day. There's a couple of bonus ones on your work today. Yes, you must do them. Also, in my class, you are going to do your rotation rules, write them 4 times, and you are going to do a mathematics chart with everything on it, even the simple interest, compound interest. And I really, really, really want us, and I know it's late in the game to do this, but I want you to make these H's for lateral and total a big H, okay? So this should be surface area. Here is the 2 formulas you're using for surface area. This is for volume, okay? And then let's see, we have slope here, and we have V for volume here, and then we've got Pythagorean, and this is for interest I, and this one will solve for A, account balance. Okay, so if you wanted to write yourself another I and A, B, you could. All right, and now I want this. I want your 4 times for dilations, and you must do the bonus questions even if you don't think you need them.